In this first problem, we want to subtract these two numbers. So we grab a calculator and subtract them the way we normally would, keeping all the digits. And now we want to properly report this in terms of significant figures. So what we do is we scan the first number and we find the rightmost significant figure, and let's mark that. Then we scan the second number and find the rightmost significant figure. In this case, it's the 0. And finally, we look at our calculated result here, and we go along starting at the left. Here's the first column, here's the next one, here's the next one, here's the next one. We see that this is the final significant figure for this number, so that means this is going to be our last one. So therefore, we would report this result as 2.693 seconds. In our next problem, we want to add together these three numbers. So we line them up and we start adding the normal way, and this is what a calculator would give us. But now we have to take into account significant figures. So we scan along the first number and we find its rightmost significant figure. That's this one. We scan along the second number and find its rightmost significant figure. And we scan along the third number and we find its rightmost significant figure. And then we scan along our result here and we keep on going until we hit the column that has this significant figure. So in other words, we will keep up to here. Now in this case, we're not going to report 20.6 because we look beyond it and we see that, this is like an 8. So we're going to round up and we're going to report this as 20.7. And the units are kilograms in this example. In this next example, we're multiplying together these two numbers. So we just grab a calculator and we multiply them out, keeping all the decimal places. And this is what we get. But now we want to properly take into account significant figures. So our rule is we look at the first number. It's got 1, 2, 3, 4 significant figures. The second number has 1, 2, 3. So whenever you're multiplying numbers together, choose the number that has the smallest number of significant figures. In this case, it's 3. And that means our final answer should be reported to 3 significant figures. So that should be the 580. And I can ignore these. So I would like to report this as 580, and the units are meters squared. But now we run into a further ambiguity, because you'll recall that when you see a number that's written like this, it's written as an integer, no decimal point, and the trailing number is a 0, then we don't know how many significant figures this really has. This could be interpreted as just having 2, 5, in other words, the 5 and the 8, or 3 significant figures, the 5, 8, and the 0. So when you write it like this, you may recall this is the ambiguous case. But we know in this example, when we multiply these two numbers, we want to keep this to 3 significant figures. So the proper way of reporting a result would not be like this, but rather we should write this instead in scientific notation as 5.80 times 10 squared meters squared. And this is a better notation because now we can clearly see that this is 3 significant figures, which was what we wanted here. In this final example, we're dividing these two numbers. And the rule for division is the same as the rule for multiplication. So the first thing you do is you just grab a calculator and you find the answer, keeping all the digits. And now we worry about the significant figures. We find the number that has the least significant figures. In this case, it's this one because it only has 3. So we're going to keep this result to 3 significant figures. This. We'll keep these 3, but we notice if we look beyond it, we see the next digit is an 8. So instead of writing this as 1.16, we're going to round up and write it as 1.17. And notice that this has 3 significant figures, 1.17 as desired.